Good afternoon, everyone, and welcome to day 2 of the IOSH Railway Group virtual conference. And it's so good to see so many of you joining us online today. I'm David Porter, a member of the group committee, and I'll be chairing this session this afternoon. As part of our Mind the Gap conference theme this week, today we are going to be looking at understanding and actioning risk. And this afternoon's session will be focusing on safe and secure digital assets. We have George Bearfield with us today of Rock Rail Holdings, who's going to speak on this topic. And I'll let George introduce himself. Over to you, George.
Thank you. I'm very happy to be here presenting on the IOSH webinar today. My topic is safe and secure digital assets. And for those who don't know, my name's George Bearfield. I'm Director of Health and Safety at Rock Rail and visiting Professor of Rail System Safety at the University of Huddersfield Institute of Rail Research. To start off, just a little bit about Rock Rail. We're a rolling stock leasing company, an investor and an asset manager. And from a sort of standing start in 2014, we've secured about £3 billion of investment into the UK railway with 5 separate rolling stock fleets. Rock's very focused on benefits to passengers and sustainability. So all of our fleets are either bi-mode or electrical. And there are, the company has strong plans for growth in Europe and beyond. So, we're here for good. We see ourselves as a key and growing part of the rail industry with a keen interest in developing the best possible assets for the railway. And what I'm going to be talking about today is safe and secure digital assets. So we know that the railway is going through a fairly major transformation. It's a digital transformation that's much trumpeted, and there's a lot to think about there, particularly around safety and security, and making sure that the fundamental challenges of this transformation are met. And essentially that means with the complexity, safety and security management needs to be whole life. So there needs to be the right focus on design for safety, design for security throughout the whole life of an asset to make sure that it is fit for purpose. So as I say, it's an evolving railway. And if we look back at the transformation which is underway and has been ongoing for some time, the classical railway is electromechanical one. So if we go back to the old technologies, and the example here in the picture is a mechanical signal box. It's a good example because actually the functionality of those old electromechanical systems was well understood. It was transparent to the user. And it was, the user had local knowledge and local understanding of how things functioned, which was useful in terms of particularly if things went wrong, because it makes it possible for the local user to diagnose what's wrong, to fix it, and to improvise in failure circumstances. Whereas digital railway, the new technology that we are working with is more complex. It's less transparent in many ways, and actually the deep expertise and deep knowledge to fix things and to evolve it generally sits in very localized global centers of expertise. So that transparency isn't there. That ability to innovate or react when something goes wrong in the moment is not the same either. So it's fundamentally different, and it sets fundamentally different challenges for how we go about making sure that we are assuring ourselves from a safety and security perspective. And a good example of the sorts of risks that we might need to be thinking about comes from the aviation sector. I think many people will have followed the accidents and the aftermath and investigation of the accidents that happened to the Boeing 737 MAX aeroplane. Essentially, that arose because two major crashes of that plane arose essentially because the design, in order to enhance the airworthiness of the design of the planes, and this was given the fact that they had new engines to increase fuel efficiency, there was an angle of attack sensors which were put into the plane to make sure that under certain circumstances it kept the right trajectory. And in effect, those were not duplicated in the design, and under failure conditions, the train pitched erratically downwards and caused those two accidents. So what we're talking about here is a very complex design issue, and to address it properly needed a clear understanding of the hazards and the risks throughout the whole process of design, development, approval, authorization and operation of the plane. And the reason why this is particularly interesting is that I think particularly if we come from, as I do, from a rolling stock leasing company, the sorts of technologies which are used on aeroplanes, the sort of fly-by-wire technologies for computerized control, are very similar to the modern design of rolling stock, with a centralized train control and management system linked to subsystems and diagnosis of function and data to control the whole system. So there are many similarities, and we are on a similar trajectory to that sector. And as well as the technological changes, there are more subtle changes occurring as well. So people's expectations are evolving over time. It's well known, and I think well understood by many people that with each generation, there's a rising expectation around health and safety, and we can see that in various cultural and practical changes which have happened over the years, from increased wearing of seatbelts many years ago to now more of a recognition of the hazards of smoking, and in recent years much more of a focus on mental health and well-being. So as I say, people's expectations around health and safety and what they expect is gradually rising. And in particular, passengers and the public expect to be safe when travelling on the railway. And in fact, the UK, compared to other railways, the UK has a good record in this area. We had some major train accidents in post-privatisation, and we learned a lot from that. I think the UK rail industry is characterised by having a very open, transparent learning culture around safety, good sharing of information, and that is evident in our safety performance figures. The Carmont derailment as a result of a landslip which happened recently was the first time there'd been fatalities in a derailment or collision for nearly 13 years. I think that there isn't the same risk now on the railway as there has been in the recent history, but having said that, people's expectations are only going to increase further. And as regards digital complexity, there are some indications of some of the risks that might be there on the horizon. There was one particular one here, which is on the Tsuen line in Hong Kong, where a design error in automatic signalling protection led to two trains going over the same crossover at the same time. So that was again a complex design and development issue, which resulted in a real-world accident. And closer to home, at the end of 2017, the pilot application of the ETCS signalling system on the Cambrian line in Wales had a inherent design fault, where in effect the temporary speed restriction information was not updated to the trains, and actually the design meant that it was not possible to for the control room to spot that. So fundamental design issues to do with complexity of these systems was the root cause, and what actually occurred was the trains on that line actually went overspeeded, including on the approach to level crossings, which meant insufficient sighting time. So there were real world risks associated with some of this. That Cambrian line has been a shot across the bows for the industry, and a very detailed RAID report with some far-reaching recommendations, one of which I will speak about later. So we've got all this complexity to deal with, this fundamentally different approach to how we go through about safety and assurance. But we also need to throw into the mix the new risks which are coming about as a result of digitalisation. So whether it's the signalling systems or these new networked rolling stock systems that I've already mentioned, they are inherently prone to cybersecurity breaches because they are connected systems that work on computer networks. And actually, over the last 10 years, there's been a steady trickle of state-sponsored, attacks on critical national infrastructure. And of course, the railway is critical national infrastructure, but there have been attacks on power stations, there's been attacks on other critical facilities. And the term for this within the cyber world is ICS, instrumented control systems, and also there's talk about operational technology. So we know these systems are the critical national infrastructure is being targeted by nation-state actors. The most high-profile example of that back in 2010 was the Stuxnet virus, which was attributed to US and Israeli intelligence services. In effect, that virus got into the systems of the Iranian nuclear program and damaged centrifuges, setting back the Iranian nuclear program. An example of what happened there as a result there was that the technologies that were used, which were exposed as a result of that attack, were highly complex and beyond realms of what people thought was credible at the time. But then, having been exposed, they did spread into the network of cyber criminals and cyber actors, and did become, those techniques have then been used on a more widespread basis. So the message here really is that from a nation state perspective, there are actors out there who are developing, in an almost literal arms race, are developing highly complex highly complex approaches to attacking critical national infrastructure. And once those techniques are used, they will be available to be used by a broader set of actors. The last one there, Triton, was actually an attack on a Saudi Arabian power facility and deliberately attacked safety instrumented systems. So it was a deliberate attack on some of the safety systems there. So again, there is an emerging risk here. It's really hard to quantify, but the very nature of the fact that we have these now connected computer-based systems creates the vulnerabilities and the potential for these risks to be realised. So if we go into safety by design, the way to deal with these emergent risks is to really understand the hazards, safety hazards, and latterly the security vulnerabilities, and to really think about those through the whole life of the asset, right from its concepts and platform development stage through its whole delivery into its operation and maintenance. So that, you know, there are safety requirements which need to be understood to address the hazards and implemented from the earliest possible phase in a project. And this diagram, I think, is taken from the RSSB document, Taking Safe Decisions. You know, it's a well-known fact that the longer in a project, the later in a project, the need for design changes arises, the harder it is, in effect, to implement them. And on any realistic project, there has to be some compromise and some optimization. The point is, you really need to understand those safety hazards and security risks at the outset to be able to ensure that the right requirements are in place to address them and to minimize the risk. And there is if you go to the standards and the accepted approaches, there is a idealized process for doing this. Is the waterfall model, the V&V life cycle. Essentially, that is premised on the idea that the requirements can be sufficiently well understood at the start of the project. You design, you specify the requirements, you design your system. The requirements are cascaded to lower levels of abstraction with checks to make sure that nothing is missed, to get down to the level of detailed design. And then as that design is built up again to the full system, there are cross-checks, validation checks to make sure that everything is done correctly and those requirements are correctly addressed. So it's a well-accepted and classical process, but the assumptions that underpin it are ideal. It is the case that you don't always start with that clean sheet of paper and the opportunity to influence the design to that extent, but that is the way in which this model and the assurance that it brings is premised. So I think of it a bit like running a relay race. There are a whole range of different actors in this process, and everyone needs to hand over that the baton, and the baton is the understanding of the hazard, the vulnerability, the safety requirement. That consistent understanding is needed right from the concept phase right through to the delivery of the asset. And if you like, the classical V&V life cycle is based on an ideal relay race. So all of the runners know exactly what they're doing. They know when the handover points are going to be. They're well drilled, they're competent, and the whole race progresses at the right pace and the right speed. But actually, we don't live in an ideal world, and these transformations which have happened to technology have also disrupted the way in which systems are delivered. So we have, as I mentioned before, a global supply chain with local pockets of expertise. Most major rail assets are designed and developed significant investment, and they're designed and developed as a generic platform. They're not designed with the specific requirements of any given project in mind. And also they make use of subsystems. So you may have, for example, an item of rolling stock, it will have subsystems, braking systems, door systems, cameras, which are actually brought in from sub-suppliers. So actually we don't have this classic relay race, this V&V life cycle where everything is under control and can be fixed through the process. It's almost as if the relay race is actually run backwards. So we have the asset built to a generic platform with a generic understanding of the safety requirements. We then have these individual subsystems which are brought together to help build the asset. They are certified as products, often safety certified according to standards as individual products. Then the whole thing has to be integrated together, and then it has to be configured with application data. So if we think particularly, again, I'm thinking about rolling stock, where we have things like selective door operation, where doors only open at certain platforms on certain routes. That all requires a detailed local knowledge of the safety requirements and the way in which the system is going to be implemented. And in practice on a project, because of this development life cycle, that specific knowledge about the safety requirements only comes at the final stage when you're actually seriously considering the operation, maintenance and use of the asset. So in some ways, we try and run that relay race backwards, but ultimately that consistent understanding of safety requirements and security requirements needs to be run like a stick of rock through the whole process to make sure that to ensure that there isn't any suboptimal design trade-offs in the delivery of the asset. So this life cycle is a good conceptual model, but it isn't actually the way things work in practice. So there's a need to rethink that. There's a need to rethink what actually is done and to refine our understanding and the ways in which we formally require safety assurance and verification and validation activities to happen if we want genuine assurance and if we want the formal processes to drive the right behaviours. Another aspect to this is the regulation. So from a safety perspective, there is this regulation, the Common Safety Method for Risk Evaluation and Assessment. That's a European regulation, but it's relevant in the UK and I believe will persist beyond the Brexit transition. So in some ways, this is a good process. It describes that exact process we've just been talking about around identifying hazards, understanding how the control measures and the safety requirements and ensuring that they're implemented. And in this case, if it's a significant change, like the introduction of a new asset, there's a requirement for an independent assessment body to check and confirm that that process is applied. So all well and good. The weaknesses, though, are that it can be quite a light touch approach. And because of the fact that it's written as a flat process here, not as a life cycle, it has evolved to that often many of the parties only see the information appearing late in a project, which can be counter to that broad engagement on design for safety that I previously said that we need. And another thing which links back to this idea about platform development and development of individual subsystems, this regulation incorporates the idea of reference systems. So in fact, if something has been assured on a previous project, that information can be co-opted and used in the new project. Now, the problem is it can hinder transparency. So, for example, if you're buying an asset, you actually want evidence which was generated from previous projects to be visible and transparent to you to be able to get the assurance that you need. And this has been recognised, I think, to an extent in the RAIB recommendations from the ETCS Cambrian line incident that I discussed previously. And just part of that, it says that Network Rail, in consultation with RSSB and the wider railway industry, and drawing on existing processes where appropriate, should develop and implement a mandatory safety assurance procedure and associated guidance for its client role on projects involving installation and modification of high integrity software-based systems. So I think this is kind of a recognition that, yes, the asset designer manufacturer has a key role to play in the process of this complex digital design, and the assessment body has a key role, but actually the client does as well. So the client needs to be clear in what they're specifying around this work, and also needs to be needs to understand, to be able to understand and have confidence in the outputs of that process. So as one of the roles I'm currently doing, I'm chairing the RSSB Asset Integrity Group, which is actually working with Network Rail on addressing this recommendation. The current proposal is that a railway industry standard will be developed to formalise some of these aspects and strengthen this aspect of the process. And again, if we look at the way things could or perhaps should be done, we can look into the fairly recent past. For those who've been in the industry and working in these sorts of fields for 10 years or more, you'll remember something called the Yellow Book. This is actually a more detailed process consistent with the Common Safety Method regulations and the key software assurance standards. It's a life cycle based approach that used to exist and was fairly heavily applied throughout the whole rail industry. It was discontinued over time because I think it was felt that it was seen as onerous. But I think when we revisit these, the requirement from RABE and the sorts of things that the industry needs to get more assurance around the complex systems in the rail industry, I suspect we will be going back to the Yellow Book to look at some of the things that it actually did quite well. So it specified the need to think very early on about your preliminary safety argument to get a degree of formal approval and assurance around your safety argument at an early phase in the design, such that there was confidence that the safety requirements would ultimately be met. And I know that the many aspects of the Yellow Book process are still actively used within Network Rail and TfL, London Underground. So, I think that there are some really good aspects of this document which practically really assisted in making sure that when we got rid of it, we didn't throw the baby out with the bathwater. So, I mean, that's a fairly quick run through the safety by design issues. These systems are complex. They potentially disrupt the traditional ways of working in terms of the ways we get assurance. But there are ways and means to get that assurance if we proactively address it and if we engage all parties. So not just those manufacturing the systems, not just those who are doing the independent assessment, but the end users and operators, and actually the clients, the people who actually own the assets longer term. There's a need for all of us to engage on that, getting that greater visibility of assurance. But as I mentioned before, digitalisation is creating new risks. And so we can talk a little bit now about this concept of security by design. So as I said before, there are emergent risks for operational technology, which railway assets are, and these potential vulnerabilities and challenges to our critical national infrastructure through some of the examples there. As I said before, this is a literal arms race, so there's a huge amount of effort going into for different nation states to develop these capabilities because they're of strategic importance. If we look at the Black Energy incident, that was a case where it's strongly believed that Russian forces disrupted, I think, 30 Ukrainian power stations in a highly coordinated attack. So the power stations were disabled through malware. There was actually then a coordinated attack where backup power supplies were sabotaged and remotely, and there was also a case that the phone lines were bombarded with sort of denial of service attacks, so that customers couldn't actually contact the customer services. So these technologies do exist, and they're being developed because of the strategic value at nation state level. And this is a graph I used some time ago. Could probably do with a little bit of updating for exactly where some of the lines are, but this is an entirely unscientific view from my own experience of many years in the rail industry about sort of relative concerns. So if I go back to sort of time of privatisation, operational safety, particularly after accidents like Clapham Junction, Ladbroke Grove, was a really high priority. Performance and reliability too. There was less avert discussions around sustainability in the environment and less around security, and particularly, obviously, technical security of the type that I'm talking about now. But there's been a, as I say, you could argue about where the lines exactly are, but there's been a gradual change in that focus. Certainly, environment and sustainability has come much higher up the agenda. I probably would put that line a little bit steeper if I was to update this graph. Performance and reliability, certainly pre-COVID, was a real issue as the network was becoming crowded. But actually, operational safety was still a high priority, but because we've made progress, it was relatively less of a concern. But I think that the security risk has kind of come out the traps as a steeply growing one because of this, because of the commercial and nation state implications, and because of the way technologies evolve. So, and it is also the case that security incidents can cause safety effects. So there is a view, I think, I certainly have a view that, although we could quibble about the exact shape of the lines, that at some point we will need to think more about operational safety and security as an overlap, and that will need to be something which gets more and more focus over time. And coming back to the Black Energy attack, where the Ukrainian power supply was attacked remotely through a cyber attack, ultimately the only way that the Ukrainian authorities and government were able to take back control was through manual circuit breakers. So if we come back to the previous discussion around this electromechanical to digital transformation, ultimately they were able to get the systems back online because they had mechanical circuit breakers. It's a bit like if you were to get, if your router at home was to get hacked by somebody in a car outside, well, at least you can switch it off the power supply, directly connect a wire in, your LAN in, and change the password. So it's important to be able to have that mechanical control. And the US government has recognised this and is actually putting in legislation in some places to ensure that things are not fully digitalised, that there is always that sort of local or hardware-based ability to recover. Now, I say this is an emerging area, and the UK is well placed to deal with it and address with it, given our competence, national competence in this area. So if we look at legislation and standards, most people I'm sure will be familiar with the NIS regulations, which came in 2018. In effect, these are place duties on what are called operators of essential services to digitally secure their assets. And there's almost two camps here. There's your classic business IT systems, and then there is your operational technology. I think my learning from the more I dig into this is that a lot of the cyber expertise in terms of how you defend networks from intrusion and monitor attacks as they're underway tends to sit within the traditional IT discipline. It doesn't naturally sit within the community of people who are engineers who are responsible for the critical national infrastructure, be that signalling or rolling stock. But that is changing, that is evolving, but it isn't yet mature. So I think one of the challenges for the NIS regulations is that they do bite at the operator of essential services. So essentially in the rail industry, Network Rail, the train operating companies. Now, in order for them to be able to meet their requirements, they do need assets which have been through a good security by design process and which are capable of being monitored for the right threats and intrusions as they occur in operation. So that does require a degree of foresight, and then we're back to design for security. So some of the same sort of thinking that needs to happen around safety hazards through the whole life of an asset needs to happen through security vulnerabilities through the whole life of an asset. And the regulations are not so finely attuned to enforcing that and making that happen. And the standards, again, are less well developed in this area. So there's a suite of standards, IEC 62443. They basically specify a similar sort of life cycle design process to the software standards, but they aren't focused on railways. There is a railway standard as a technical specification in development, but again, it's not mature. So at a high level, I think the issue here is that if we look at safety requirements, we look at general technical requirements, we have legislation and frameworks, including independent assessment, to make sure that they are addressed through the life of the design of an asset. There is not the same framework in place for cybersecurity requirements Again, this comes back to the parties, for example, the client, to understand that and to make sure that contractually there's the right incentives and motivations in place to address those requirements in the same way, because they are, for reasons I've already outlined, equally important. And again, so as I was saying before, those emerging standards for design for security are based on this classical, idealized V&V life cycle. And, you know, as I've already said, that isn't the way that the world works with these global supply chains, platforms being developed and then customized. So there is a need, as things evolve, to rethink how this process works and to make sure that what's actually being specified aligns with what actually happens in practice on projects. Again, I say this is not yet mature, but this rapidly evolving field, and there is guidance and consideration underway. IET, I think only this week, has produced its code of practice on cybersecurity and safety, and it stresses exactly these points. Cybersecurity and safety are both design issues. They need to be thought about through the design of an engineered system. They need to be thought about together. In some cases, there may be trade-offs, at least theoretically. And so the IET's engaged with that and has produced a code of practice. So these techniques and approaches are evolving. And I think I alluded to it before when I spoke about the IT expertise not naturally being owned by the engineers who are traditionally developing signalling and rolling stock and other railway systems. I think this, as well as the guidance, there's a need for evolving the competence such that there is sufficient understanding of IT vulnerabilities within the engineers responsible for the operating technology. And this is where we get to the sort of some particularly challenging issues, and so I've worded it as transparency here, but I talked before about the real improvements that the UK Railway had seen in safety over a period of sort of a generation. And that was born really of some tough learning, I think, in terms of, you know, we had major accidents like Catfield, Ladbroke Grove, Clapham Junction. And there was a realisation within the industry in dealing with those that what was really needed to ensure safety was a really open learning culture. You know, the ability to openly talk about incidents that happened and, you know, not just accidents, but precursors. And to share that information in a very open and transparent way, such that others can learn from it and ensure that those accidents don't happen again. And I think, you know, it's a real, you know, we have systems in place like our National Safety Incident Reporting System, SMIS, like the NIR system, which openly shares information around rolling stock faults, which are almost unique in many ways in terms of their openness. And it's been very difficult for others. I know there's been moves, for example, in Europe to replicate those systems at a European level, and they've been very difficult. And the technology is not difficult. It's more the cultural issues and the willingness and openness around sharing information. Now, remember, I've just said that the safety and the cybersecurity need to be dealt with in an integrated way, but that same approach to transparency it has different challenges in the security domain, obviously, because there are some people that we don't want to know about security vulnerabilities and the particular ways in which systems can be circumvented. And there are also, I guess it's because by definition, we're dealing about these detailed design issues, which are held in these global centres of competence. Inevitably, you get into issues of commercial competence as well. So I think the real challenge here is a deeply cultural one. We can do things around the frameworks, we can do things around the legislation, but ultimately we need to get to a position where safety and security are being dealt with in a integrated or aligned way in terms of transparency and openness of learning and information. And I'm not sure what the answer to that is, because if we were to restrict access to some of the safety information, what would the implications there be around the open culture that served us very well around safety? Similarly, if we were, you know, we're not going to be in a position to share some of the security incident information in such an open way as we do with the safety information. And yet, as I said before, they're both design issues that need to be dealt with by the same or similar people at the same time in a project. So we're just going to have to work through this one, but I think actually recognising that it exists is a start, which is one of the reasons why I'm raising it today. And actually, in some ways, we're not institutionally set up in a way which is naturally going to resolve some of those differences. So in terms of regulation, ultimately the sort of regulatory responsible for cybersecurity is with the Department for Transport. For safety and some of the system safety issues, it's with the Office of Rail and Road. Now, obviously, if there are security issues which have a potential impact on safety, then by definition, they're within the ORR's remit. But I guess if you were just looking at these two issues, you would say that having a single regulator responsible for both would be the best way to set the environment to work through some of these challenges that digitalisation presents. Interesting to note that that common ownership of the issues does exist elsewhere, and I'm thinking particularly around in Australia, and actually they've done some good work in their guidance and processes around dealing with these issues, which probably is not entirely divorced from the fact that there is a single accountable authority at the top. And again, I alluded to the fact that some of the regulations need to evolve here around cybersecurity. It is a potential regulatory gap at the moment that there isn't the same independent regulatory processes around cybersecurity requirements that exist for safety requirements and technical requirements. So we have the whole notified body, designated body, assessment body process for bringing and authorising assets into service. The parallel processes for cybersecurity requirements don't yet exist, which again is one of the reasons why some of those things need to be addressed contractually until such time as they do. Ultimately, whether there's cybersecurity whether there's issues caused by cyber or through more classical system safety design issues, risks need to be managed as low as reasonably practicable. So there does need to be an integrated consideration of these issues. So the way ahead, and I think, you know, this is just kind of a summing up really. We've got to create the environment to deal with these issues. At this stage, you know, these are emergent issues. We do, as the UK, have as a nation, we have world-class, admirable knowledge and understanding of these issues. So we've got all of the pieces of the jigsaw puzzle to work this through. But we do need to think about all aspects. We need to think about the regulation. We need to think about the standards, whether the standards actually are fit for purpose regarding the ways in which these technologies are developed and brought into use. We also need to think about the project delivery and the processes and the assurance, how it works in practice, and how we get that relay race to work as effectively as possible, and for the safety requirements to cut and security requirements to cut through the whole project. And we need to think about these transparency issues. How do we control the information so that all the people that need to understand the hazards and the vulnerabilities do, but those who shouldn't have that information don't? Which does lead me back to safety culture and behaviours, and this is a quote from Peter Drucker, the sort of management science guru: "Culture eats strategy for breakfast." So, you know, unless we get those cultural issues right, and unless we get the right working around some of the learning as we progress in this very dynamic area, and we won't be as successful as we could otherwise be. So ultimately, despite the fact I'm talking as an engineer and most of this conversation has been about some fairly deeply technical issues, ultimately it's the culture, safety and security culture and behaviours that we will need to address. So that was all for me. That's the end of my presentation. I am going to be staying on for some questions. So please do, if you have any questions, do have a think and put them to me in the next session.
Thank you very much for that. That was very enlightening and challenging. Just while, let me just check, just while I wait for some questions to come through, can I ask one of my own questions first? I want to pick up with that idea that you came towards the end about culture. And some of the questions that were coming to me from your presentation, which was technical, big picture, and was actually human factors aspects of the design process. Two aspects struck me. One is that we've got a multidisciplinary design process with different specialities who talk different languages. and we've got evidence in the past of a lack of challenge, you know, and we know lots about thinking biases and that sort of stuff. So how does the human factors safety person interface with that? And the other thing is you've got a human interface with such things as control rooms, which are signal boxes and driving trains. And I wonder how those human factors aspects are actually woven into the hazard analysis and risk assessment processes that you've sketched out for us.
Thank you, David. Whoa, don't know. There's all sorts of angles to that. I mean, I think thinking about the presentation, there's another angle to culture actually, which is of course cybersecurity culture, the behaviours of individuals as an above technology to prevent the vulnerabilities and to minimise the the chances of using a duff memory stick, or there's that angle as well. I mean, I guess it's a danger between setting a challenge and coming up with a positive way forward. I think all I can say is I recognise that all those challenges exist.
Yeah.
I think we are going to have to go on a bit of a journey to work things out. I mean, there's some classic things like if you've got a trade-off with safety risk and where you're traditionally working in, not so much on the software safety, but you're traditionally working on a reliability, logical, risk is always an estimate, but at least you're doing it in some sort of objective, logical structure. And then you've got some risk from cybersecurity, and potentially if there are trade-offs, and the IET guidance does come up with some of those trade-offs, how do you actually balance one against the other to come to an optimal solution? I think that's an open research question, unfortunately, and the only answer would be you get the right people around the table and you have a bum fight over it. So I do think, I think there are challenges there. I guess where I was coming from was, how do we create the environment to get the right people in the room? So some of that's about skilling up people with good skills in one area with the knowledge and skills they need in another area. Some of that's about people recognizing the challenge. Some of that's about getting the regulatory environment right. Some of it's about having, I've worked for an organisation that purchases assets, and actually there's a certain level of information you need to know, even if you're not doing the design, to be able to set the environment for the project to progress. So I think all of those things need to be worked through, but I do think we're some way away from having a recipe book to do this correctly. So there's several, I think there are several open research questions for us to work through to be able to do this as efficiently and effectively as possible. But unless we get the environment right, we're not even going to get to those research questions.
Yeah, it's not my area of speciality, but having a human factors person somewhere as part of the team, observing the reactions of the team and the thinking of the team, as well as the design process itself, would be perhaps potentially a step in the right direction, wouldn't it?
Yes, absolutely. And I guess, I started out as an engineer, but ended up, when I was at RSSB, having the human factors team in my area. I was slow to catch up on the importance of people in everything as an engineer, but when the penny drops, and you realise that that's where it begins and ends.
Well, these things have tripped us up in the past. I've got a question here for you now, George, from Ed. Would cybersecurity be better managed and coordinated from the DFT rather than devolved to railway and air systems? Do you think there is sufficient expertise available?
I have got a relationship with the National Cybersecurity Centre, where there certainly is, as I said in the presentation, world-class expertise. The one thing we're not short of is knowledge about these threats and how to protect against them in the UK. And there are mechanisms in place to leverage that knowledge. I think there are, of course, that ultimately it's a complex issue, and everybody needs to have the competence to do their role. I do think the Department for Transport, on both the safety and the security sides, and this is probably more pronounced with changes, post Williams and COVID, where the roles and responsibilities are changing. I do think there is scope for the Department for Transport to understand more about the link between the technical challenges and the client role.
Right.
And in effect, I mentioned the RABE guidance, which talks about client level responsibilities. It's not about being a deep technical expert, but it's about understanding these risks and challenges and being able to set the environment and the frameworks to be able to get assurance. And obviously working for a rolling stock company that's made significant investment in the rail industry, I see similar challenges for us. And so often I feel like I'm thinking like the Department for Transport on some of this stuff, because we're dealing with such large sums of money for the assets, and we're looking at long-term value and minimizing risk. So I think there's scope there's scope for all parties. Everybody has to play a role. I think there's the big challenge is upskilling people in the different areas, so they've got the right level of competence to play their part, which was kind of the relay race bit, really.
Yeah. I think what you're talking about there perhaps is the what perhaps in nuclear and the petrochemicals they would call the intelligent customer capability.
Yes, absolutely.
That sort of idea to know what you want and be able to be discerning about what people are telling you.
I think that's true, and that's true on both software safety and cybersecurity. And I think that's the way that the response to the RABE recommendation will likely go. It will draw on guidance that's been produced in other sectors as well. There's no point reinventing the wheel. Yeah. So yeah, I would agree with that.
Can I just ask you a practical question about as a rolling stock provider, you're developing systems with certain technologies. How does that sort of mix in with the idea of the digital railway and the signalling? Because obviously Network Rail have their own ambitions and requirements, and you have yours. How does that actually practically work together? Is that a relevant question for you?
I think it is, and I think it's a critical question. Hold on a second. So I think that's it is a pertinent question in that obviously the bulk of that work for digitalisation of signalling has still to happen. Mm. So we're again at the early stages of maturity here, and I know there's lots of good work being done in terms of planning all this. I think there is, for me, so most of the rolling stock, well, all the rolling stock that we've bought comes fitted with ETCS and ready to be implemented for signalling system, for projects. When we do that, I will certainly be very interested in how we deal with signalling as a system. So it's obviously one structural subsystem within the TSIs. Yeah. Delivering it as in two separate stages, conceptually has some obvious potential issues, which is making sure that the requirements are consistent across both, that those interfaces that you're creating by just carving the project up in that way are managed. It's almost a bit like the railway, isn't it? The railway is one railway, but we have train operation and we have infrastructure management. And of course, it's that interface where all the friction points are. So it's that writ large with the technology is how are we going to address and deal with that. And I think it comes down to the same issues, which is good upfront planning, good requirements management, making sure that that certainly from a safety perspective, that there are clear milestones where safety progress is reviewed and arguments are checked, transparent verification and validation processes. The compatibility point is an interesting one, I think, particularly around ECCS as well. So I guess would Network Rail tend to be the people who are doing compatibility as they are at the moment? Or if the project's carved into two, is it somebody's doing compatibility from one perspective and from the other? I'm sure there are answers to all these questions when you get closer into the projects, but I do think ETCS does throw all these challenges into fairly sharp focus, I think.
Yeah, and I think long term there's potential. We were talking this morning about trackside safety. So, we were talking about not shifting the problem to the signaller in terms of workload and complications. And similarly, we could make drivers' jobs a little bit more clearer by them knowing where people are on the track, that sort of idea as well. Can I move on to a question here from Russell? He says, slightly going off piece, but it's related. I feel the interface between software engineers and nuts and bolts engineers could be better. What's your thoughts, George?
Yeah, well, it's interesting because I trained as an engineer, analog electronics engineer, and then did a master's in embedded systems. So I've always come to computers from the transistors out, if you like. Yeah. But I think you're right, and I think it's a way of thinking, isn't it? I think there could do software engineers really, how well do they understand systems engineering concepts? And, you know, in terms of your traditional engineers, you know, particularly on the software and safety side, how much do they understand computer networks? And, you know, I think there are some that do, obviously, and there's some that have had the right training, but I don't think it's something that naturally comes out of the education system, or that people are naturally channeled towards having. Having said that, I'm sure the education's moved on a lot since I went through it. but I do think that certainly they're merging, aren't they? The disciplines are merging, and one way of looking at it is the challenges that face the railway are a good opportunity to realign things and you know, create really interesting careers and development paths to address those challenges.
Okay, thank you, George. I haven't any more questions, so I think I'll draw it to a close now by saying thank you so much for your time. I found that most fascinating and some really significant challenges for you and your team in the future. So thank you again. Before everyone goes, I'd just like to say that if you're not a member of IOSH or not a member of the Railway Group, please take time to look at the IOSH website and the IOSH Railway Group microsite within that to familiarise yourself with the sort of work of the activity of the Railway Group. And remember that tomorrow at 10 AM we will continue our conference with a talk by Simon French from the Rail Accident Investigation Branch. So all the best. I hope to see you tomorrow. Goodbye.